All right. Welcome back, everyone. It is Monday, June 23rd, 2025. This is the Virtual Residency Workshop 2025. Our next session is CI user support. Our speaker is Chris Reedy from University of Arizona. And take it away, Chris.
Thanks, Henry. So I'm glad to be here to share this information with you. I got some help getting my screen set up so that I can still see the chat window. So I'd like to encourage you to put things in chat. I may respond to some that I see, and some will be just useful information that you can put in there. I'm the I support facilitation at the University of Arizona. I manage a team of currently five. Previously, to Henry's point about where we come from, my background was business and law. Those were my degrees. And then I decided at a very opportune moment that I did not want to be a corporate lawyer. So I followed a different path, and here I am. These are some of the topics that I'll discuss over the next hour and a bit. Notice that I have stories as the last one, not because I think stories are not that important, but it gives me a little fudge time because Henry pointed out that dead air is the enemy of these presentations. Also up on the top, you see I put a little AI thingy, and it seems like AI is hanging over us and everything that we do. So just a quick comment on something Sarah put in the chat on the last presentation. I think we're in a good position to be users of AI and not the people who will be replaced by AI. And I know we have more AI conversations going on during the week, so I'll just leave it at that. So at the University of Arizona, we are organized under the Central IT. Uh, Across the country, something like 40 to 45% of HPC centers are organized under the CIO's office, and about the equivalent amount are organized under the Vice President of Research, the VPR office. And the remainder tend to be in specific domains, like the medical school will have their own HPC center. We have a fairly small team for supporting HPC. We have a systems team of three. We really need four. My team of five, of which there's an opening right now, so we are currently at four. We have a secure research team, and we have three clusters who are about average, I would think, for an R1 institution. There are many bigger than us and many smaller than us. So between the three clusters that we have about 45,000 cores, just sort of a common measure of size. We also have two very specific HIPAA and CUI clusters for supporting regulated research. So cyber infrastructure, what it is, those are components and most importantly, really the people who support it. And that's what I'll be focusing is on the people side. There are different definitions you can find, but I like this one: enable scholarly innovation and discoveries not otherwise possible. Henry talked about the difference between CI, cyber infrastructure, and enterprise IT. One of them that I'll kind of focus on is the way that applications are supported. In enterprise, you have the CRM, customer relationship management function. So you go to Salesforce is one of the big companies, give them $1 million, and they will set up a whole CRM system for you that requires many people to support it. And it supports the university, but it also supports a lot of other institutions that are not universities. Whereas for us, we are more focused on the users and not on the applications. So we support all kinds of non-standard software. We support software that's very restricted and licensed like ANSYS, software with usage limitations like Gaussian. There are all of the Python realm of software. So there's really a huge range of the kind of software and the kind of support it needs. So when is CI valuable? What we're doing is providing a shared environment for research teams. And by shared, it provides somewhere where they can all keep their data in one place. So all of the members of the team have access to the data and they don't have to have separate workstations, NAS storage boxes to maintain it. It's a more convenient arrangement for their support. It also is shared for computation. So they get allocations of time that they share amongst their teams. So they spend a lot less time organizing how they will do their compute if they're using our shared environment. Kind of related to that is avoiding the notion of closet clusters. They get money, they buy some equipment. The classic one that we have is some of the natural language processing faculty who are hired. They all seem to come in with this notion that they needed their own workstation. So what they ended up with is a very loud, very hot appliance that sits under their desk, and it's really annoying. But they've got their GPU workstation. They seemed averse to using us for managing that kind of uh, the resource they needed for their NLP work. And really, we can do that well also. It takes work to get set up to replace that notion of them providing their own equipment. Um, so I've got multiply the value of the funding. So they get a limited amount of funding from whatever source. And because we handle all of the installation, the systems administration, upgrades, maintenance, security, they don't have to pay for that or spend the time doing it. So they get more value out of the money that they do have for research. They don't have to spend it on infrastructure. And for scaling up and scaling out, many of the things they can do on a laptop, let's say they're doing MATLAB on their laptop, and it works quite well, and it's really gets done pretty fast. But their laptop might be limited to, say, 16 gigabytes of RAM. Our compute nodes have 512 gigabytes. So we can do a lot more, lot larger data sets. Um, we have 96 cores on the primary cluster. They might have 4 cores, 8, some much smaller number. And then they can run one job efficiently on MATLAB on their workstation, but they can't run 10, or they can't queue up 100, or even 1,000 if they're all independent, or even if they are dependent, but with dependencies set, we can run all of much more workload and take away the need for them to babysit their workstation while it's doing their job. And then really when you get down to it, it's reducing the time to science. I'll just add in another that came up in the last session about it was referred to the condo model. So in essence, researchers have funding for equipment. And in our case, it's one of the scenarios that Henry mentioned. We offer a menu of nodes you can choose from. So if you have funding to put in and you don't need GPUs, we'll provide an architected offering. And we get very good pricing from the vendors because it comes through the RFP process we have. So they can't go out and buy a Dell workstation for nearly the price that we can get the, uh, the equivalent features. So they do bring their money to us and buy one of our menu of choices. And as soon as they put in the funding, we give them an allocation. So now they don't have to take the money, buy the equipment, wait for it to show up, provision it, get all the software going, gotta find someone to do all of that. They just put in the money to us. As soon as the purchase order goes out, we give them an allocation. So for the value of CI user support, a study done about 5 years ago at the University of Colorado Boulder, and it specified the research showed the value of the operations of a CI center and that improvements in the user support operations it had a measurable improvement in the efficiency and the usage of their systems. So that's what we're all about today and here this week is about how we support our research community. So expectations, just looking at the stakeholders. So the typical roles of stakeholders, so very much for our case, it's the CIO, the Chief Information Officer. For many, it's the the vice president of research, VPR. We don't have a dotted line to that function, but we are we get some of our funding and we have a lot of collaborations. And then at the senior levels, there are a lot of meetings. So meetings may include the support of the provost, the university president. We have a governance committee, which is very important. So usually a selection of faculty and other stakeholders. And then you may also need an important relationship with the faculty senate or any other faculty groups. It's very beneficial to have one or several advocates for you who may be your power users. They carry a lot of weight at the university when it comes time for funding or support. So some of the expectations. So if they are contributing funding, they want to get value for that. And I'll um, here are some of the particular values that's provided. We strongly use faculty recruitment as one of the values. I will do probably 5 interviews or be interviewed per year from faculty recruits. They want to know what kind of HPC resources we have available, what they can get for free, what they will contribute money to. If they contribute money, what they get, what our policies are. I let them ask any questions. Often these recruitments are the the on-site recruitment when they come and visit. So I'll schedule with them and their host who will bring that person over to meet up with me, and I'll do a tour of our data center. I'll let them ask any questions. And often when they start, I'll just have a coffee meeting with them, just meet up with them, coffee, see how they're doing, how they're getting started, and just that value Henry mentioned earlier about one-on-one relationships you can build with faculty. It's really valuable. And then these other, the three subjects, funding, publications, graduations. So they want to be able to bring in, use our assistance for their funding. So they don't want to have to provide the cyber infrastructure. If we provide it for them, then they can focus on the money going to the staffing they need and the central core functions of their research. Publications, of course, and then graduation rates. So expectations for faculty or PIs, typically they may know about cyber infrastructure. They may use it, they may not use it. Some of our power users are the PIs. Often it's senior members of their research team are actually doing the work. So they may not know how to use it, but they know the value of it and they know when it's working right or not working right for what they need to do. Um, so in that case, the faculty might be researchers, but they could also be instructors, and they're using our resources for teaching. And we've noticed quite an uptick with that. More and more classes are using HPC in the instruction. It kind of started with bioinformatics because they have long been interested in computation. Uh, but now they're wanting their students to be data scientists, at least with a small d and a small s, if not necessarily career-oriented data scientists, but it can be that as well. And so really understanding how to manipulate and use large data sets is starting to become part of many courseworks for undergrads. So their expectations, they want it to be reasonably priced. And for technology, there are really two groups. There are those who want the latest technology, and for many that comes with like GPUs. So they need GPUs with lots of memory is kind of the big thing. And they want to be able to run PyTorch fast. The other group is not so concerned about technology. They just want to get things done. So our older cluster we have was implemented early, maybe near the middle of 2016. So it's coming up 9 years old. It has about 100 P100s in it, and the P100s, so followed by the V100s, followed by A100s, followed by H100s, then B100s. So several generations old, but they're still really functional for doing instruction, testing of codes, small model work, inference. And so at 9 years old, that system is still really useful. We plan to buy another one this year, and we're in the midst of that process right now. And so we need to move the old one out just to free up space. But otherwise, it still runs really well. So often the older technology is still good. It has 28 cores in each node and 192 gigabytes of RAM. So decent. So they want to get immediate access. And so when they contribute money or as soon as they start, they want access to using the systems. And so as soon as they get their account set up, they can start computing right away. They want good support, and I'll get into the support. It'll be a big subject. So expectations of users. Typically, they are the hands-on. They are the ones who are actually doing the computation. So they may be likely grad students or postdocs. Um, there are in some of the larger teams that person on the team who manages the computation, and that's someone that we work with closely. So the users, they could be an instructor, and they could be a student. So that's kind of the other part. Their expectations, the users want a reasonable allocation of time on the machine, and they want reasonable disk space to store their data. And again, that technology, they just want to be able to get things done. So they want the technology that works for them. They don't care about having the latest, greatest, especially if it costs millions. So they're happy for older technology if they get more time on it. And so on that machine that I mentioned that's 9 years old, last year, in the early part of last year, I did some analysis and showed that the so each PI gets 100,000 CPU hours per month, and at the end of the month, it just resets back to 100,000. And I determined that the standard allocations that people were entitled to weren't using nearly all of the cores available. So we upped it to 150,000 CPU hours per month. To them, getting more time on that machine was much more valuable than if we'd spent the equivalent money and bought something new. So time time on the machines is really important to them. We do not provide 24 by 7 support in person. Our 24 by 7 support is in our documentation. So if they want to figure something out or they're having a problem, we expect them to use the documentation, and I'll talk more about that. But they really need highly knowledgeable support. The campus has, they call that group 24 by 7. So that's standard university desktop support. So if there's some problem with your workstation or you can't get logged in or you can't get your desktop application to work or the Wi-Fi is down, those are often students who are hired to do that work. Um, that's not the case with my staff, who are very knowledgeable and have a lot of skills for the kind of support because it's a high level of support that's needed. So I'm going to categorize users into three broad categories: the novice, intermediate, and advanced, because they have different expectations, different needs, and then how you work with them is a little different. So you can't ask them, which they are, but you can identify them often. So by the history, how long have they been around? What kind of mistakes they might make? When they come to you and you give them an answer, how they respond to that, to you, and the kind of language they use. Not necessarily they don't know all of the terms of the trade, like caching or Slurm. But more do they understand how you're explaining things, what a scheduler is, the difference between interactive and batch. So novice users, typically they don't have much experience with Linux because they haven't ever been exposed to it, and they don't do command line. They do GUI for everything, touch, tap, tap, swipe, um, point and click. That's kind of their modality. So they may already use our kind of HPC applications on their laptop. So they may know how to use MATLAB, R, or Python, and that's very helpful if they do. But really, it's rare if they understand parallelism because those concepts don't really apply in their even their limited environment of Python. So they will typically generate about close to half of the requests we get. The kind of things that they ask for is help getting their accounts set up, to know what resources available. They need to know or often ask about the environment that we have because the laptop is just a single device, but we have a Bastion host which provides the authentication, and it's really what the word means. You know, the Bastion is that little fortress tower in front of the castle, and so that's what provides our security. And you got to go through that to get into HPC, but you don't do any compute there. It's just really for authentication. Then the login nodes explain what they are for, how they work, and then what you can and cannot do on them. And then the compute nodes themselves. They will frequently have access issues, uh, how to get logged on, a password, or being logged out. Um, I want to know how to get to open my Jupyter notebook, pretty sort of basic access things. And when things don't work, they'll get errors and they really don't understand how to parse those errors, which is very understandable because the errors are often very dense, long, and unless you know what keywords to look for, if you see, they typically won't see a capital O, capital O, capital M in the middle of the error somewhere out of memory because they just used more memory in their request and uh, they tried to use more than what they requested. So that's a common one. Uh, File permissions, they often ask about how to do Linux file permissions, which is not sort of something they really understand readily, and it's a little complicated and messy. For any of these ones as I go through, if you have any other examples, feel free to drop them in the chat. Okay, the kind of support that novice users need, expect. So good documentation. We found that the more kind of getting started information we provide, the more helpful it is to them. They come in without a lot of knowledge of how to get to what they want to do. So if you just have a basic set of instructions, they'll often look through and it'll just fog their brain because they don't really get what they're after and it's complicated. So if you have even 2 or 3 levels of getting started information, that's really helpful. Introductory workshops. Uh, so sometimes we do them in person, sometimes online. When the whole COVID thing happened, we went to all online, of course. And then even since then, we now have sort of a blend. We tend to do the introductory ones more in person, and the more advanced ones will be more just Zoom only. And then what we've gone to the next level is so we've recorded the ones that are online, and then we just offer those through YouTube. So you watch the video, and we don't even teach some of them anymore. Like I don't think we teach parallelism anymore because that's something that helps for people to go through at their own pace. We have office hours so they can come and chat with us. And I've got some more information on examples of these. Face-to-face support. So since we don't have offices on campus anymore, we do that in Zoom. Um, and then occasionally in person, but mostly by Zoom if we do that. And we really encourage, we have tools that are all about ease of use, and I'll show you some of those. And then so those are tools that make things easier. And then when they need to, we encourage them to go to CLI to do batch mode. And so they need to understand how modules work, how the scheduler works, and we try to provide samples so that they can take the sample and then adapt it to their use case. And we provide a lot of support for software. So for novices, this tends really frequently it's Python related. So if they find something they can do a pip install, after a little while they may get messed up and they'll either overwhelm their home directories with files that they've just sort of bloated and added. Um, but we spend a lot of time supporting them and helping them to use virtual environments for Python, for R, and then occasionally for Perl, and then Julia kind of works that way as well. So we spend a lot of time with making a documentation good for supporting Python virtual environments, and uh, we also spend quite a lot of time for the novices when we change the environment. Like there's a new version of R available. The new versions really mess with existing environments they've set up. Okay, so just some examples of ease of use things. So documentation. So there's the website. The URL is hpcdocs.hpc.arizona.edu. Um, we used to use Confluence because that was what was available through the enterprise part of the business. Confluence is quite good, and it suited our usage for quite a while. And if it wasn't for a particular event, I don't know if we might still be using Confluence, but uh, something happened that I can't really go into details of, but it rhymes with handsome. So anyway, we had to stop using Confluence, and the central IT folks said, "Okay, you got to move to something else." So we looked around at the something else's, and we came across MakeDocs, and so we within Python, and then we have it set up on GitHub. So we have a GitHub site set up where we manage our own documentation. So it's all in HTML. So we own our own environment now. So we're not dependent on Confluence, which is purchased from Atlassian. So it's given us a little more control of our environment and how we run our own documentation. We also looked at using the campus's web tools, but then we would have been dependent on them for management and change. So we do our own documentation, and it gives us the incentive to stay on top of it. So, for example, we'll be working with someone on a common tool. Let me just pick one, Gaussian, because we have quite a few Gaussian users. And then it'll occur to one of us like, we've had 3, 4 people asking them the same question. So we'll either create an FAQ or a little page or a blog. So we've got different ways of imparting information. So we'll add and keep the documentation as a live site, and then it also motivates us to keep it updated. So periodically we'll go through and find things that are out of date. So some announcement about a system change that was 6 months ago and doesn't apply anymore, or we'll just change it into past tense. We've had a couple of other people at other campuses tell us that our documentation is being really useful for them as a model for something they might follow. So we're quite proud of it, actually. This tool we haven't implemented yet, but I feel like this will be very helpful for users to check out the environment. So it has system status. You can see what the system's doing, what nodes are busy, what's going on with it, but also as a job viewer. Um, for users of Slurm and not our interactive environment, trying to figure out what's going on with your jobs is quite dense and difficult, and why they are working or not working as the job's still running. And if you tell them, oh, just do a tail minus F on output.log, then you'll find out what's going on. They'll just be mind blown and not know what to do. So I'm kind of looking forward to us getting this tool implemented. On demand is our most substantial ease of use tool that we've added, and we've probably been on it for 5 years, quite a while anyway. Um, so as it gets upgraded, we add more features to it. So for anyone doing Jupyter Notebooks or RStudio, it's super good. And some of these apps are pinned, so they just start readily. And then if it's a GUI type app that's not one of these, there's is a desktop environment that looks very Linux-like, and so you can run your apps on the virtual desktop. It used to be you had to know how to do X11 tunneling, which is very complicated and messy and unfortunate. So now, and it's slow. So this is much more efficient. So we encourage people to use on demand. It's when we in our quick start and getting started and our early use documentation, we focus on this a lot. There comes a point though where it doesn't work for you. And that's the point where you have to start using the batch system. And the clue to that is we'll get people saying, I'm doing my work and my session times out, or it stopped working for some reason. Basically, a timeout because it interactive is for when you're there and you're doing the work and you're getting feedback on it. Uh, Batch is like I've got work to do. I submit it. I forget about it, and when it's all done, I'll get an email or a notification my job's finished and get the results. So up until that point, we encourage them to use on demand, and then after that, start using the batch scheduler. Okay, intermediate users. The characteristics, so they've been running jobs for a while. They know how to do it. They probably have been using the CLI command line interface. They usually know how to manage their file permissions. They know how they want their directories structured, and they have pretty good problem determination skills. So if the job's not working, they can find out if it's an out of memory or what changed from the last time it was working. They usually understand the virtual environments. Um, just a quick observation on that. We used to strongly support Anaconda because Anaconda kind of had so much of the Python environment just built into it, and Conda is very good. So then, what, a year ago, Anaconda started changing licensing. So that was one of those events where the things going on outside us sort of promoted a change. So now we really, really do not promote Anaconda. And it's not just for the licensing. We found that it's really bloated, so it's large. And people were filling up their home directory space with temporary with dot files. And the other thing that they were doing is Anaconda then sets your environment. So everything you want to do that's not exactly within Anaconda gets stomped on by Anaconda. It just is a giant snake, right? So awkward. So now we use Micromamba. It's faster, it's written in C, it's not so bloated, don't have the licensing issues. So we have really encouraged our users to start using Micromamba instead of Anaconda. And these intermediate users are pretty good at figuring that out and they can switch their workflow. So we will help them with complex software. Some of the most complex software is climate software. CESM is one of them. I think that's one we never did get working. Um, it's software with lots of dependencies. They've tried to build it themselves, but they get stuck and politely come to us and ask for help. And then we'll spend hours and hours just go see working. Nice. Good for you, Tomas. That's great. So some of the software is so mixed up with dependencies and versions of operating system and libraries. We spend a lot of time on some of these, and we are hesitant to give up. And I don't know if we ever got it quite. See, that I've mentioned that one, for example. Moose is another one. Physics software. Um, so lamps has been problematic lately. It was really good for a while, and then so we spend a lot of time on complex software. Some of these are for key research groups. The rainmakers, sometimes they get referred to, the ones that bring in lots of funding to the university. They're on the faculty senate, and when they talk, people listen. So we try to help them a lot. So not necessarily the PI, but the people who are doing the work. And so we'll help them a bit if it's they say, hey, now this should be running a lot faster than it is. Why? So we'll help them with performance. Uh, we changed from CentOS 7, which was on clusters. Last year we went to Rocky 9. So we had to rebuild everything. So we spent a lot of time helping the research teams with upgrading this software. So the alternative to Anaconda is Micro Mamba. So Mamba is a kind of snake. Oh yeah, easy build. Henry mentioned that easy build and SPAC for software. We do our own software builds. Long ago, one of the super smart guys on the systems team wrote a script that handles software installations. And when we looked at SPAC and just trying to get over the hump of learning it, decided that our build script works really well. So we just keep doing our thing because it works for us. So no criticism of SPAC or easy build, but just you do what works best for you. I mentioned special requests. So people who are yeah, mini forge. So that's related to yeah. So mini forge is related to Mamba. Is it like Conda Forge is related to Anaconda? Thanks for the link. So special requests, we've actually formally set some of those up. Like if you want an extra allocation or my job is going to run out of time, can you extend the runtime of the job? I only asked for 4 days and it looks like it's not going to finish, and we'll just go and help them with things like that. So helping intermediate users with little things that don't really take away anything we provide to others, we try to be as helpful as we can. So this notion we teach them to fish rather than give them fish. So if they can be self-supporting, that's really like a win for us and a win for them. We also try to put more complex examples in our documentation. So I mentioned the Gaussian one. So there might be tricks to getting it to work with, oh, lamps is a good one. No. Anyway, there's some apps that we support that have tricky input files. So we might include, if you're getting started on Gaussian, this is the kind of thing your input files should look at, or these are common errors you'll get. And if people go through that as they're getting started on, they go, oh, yeah, I saw that. That explains it. Or proactively, like, oh, yeah, I have to remember not to do that thing because it won't work right. So we try to be a little more specific to help them. Um, we do some specific trainings. So, for example, we have MATLAB come in and do a workshop probably twice a year. So they come on site and do the workshop. So we try to give some specific training. We also have we've had a fairly consistent relationship with NVIDIA. They've come on site to do trainings probably once a year or at least once every other year. And now we have one of my team is certified through the Deep Learning Institute to get extra support. Something that I really encourage is providing thorough answers. So a good example is kind of the one that I mentioned. Um, so they'll say, my job didn't run, it failed, and they'll cut and paste in the error that they get. And we quickly look through and we'll see out of memory So if we just say, oh, the reason why your job failed is out of memory you need to provide more memory to your job request. Done. So that's a basic minimal answer. So we usually go beyond that. So our answers might be a paragraph or two or three that will say, typically in this environment, the reason is because you're doing that. One of your options could be this. You might want to also look into that. And the team have collected some of these answers so they don't have to write them out separately each time. They'll just kind of cut and paste in and modify answers that they've provided for people previously. But these thorough answers reduce the amount of back and forth. Okay, I tried what you said and now I get this error. Well, often we can anticipate what the next problem that they'll have is, and we'll try to provide an answer for the whole situation and not just a specific problem. So in that way, we're helping build relationships. And every so often, and we just had one of those recently where one of my team had a long, nice email from one of the people she's supported particularly, who said, "Hey, I just got this postdoc job in University of South Carolina, one of the Carolinas, sorry. Uh, she's going to be working in a research lab. She's so excited, and it happened, she feels, because of all of the help that we gave her to get her PhD completed. So she's super excited, and then she gave us good feedback on the kind of support that we provided for her. And then, if we don't know something, uh, just say you don't know what it is, and then try to figure it out with them. If you try to figure it out with them, that's really helpful. So, Stack Exchange is kind of losing its mojo, I think, lately. But if you go to you can Google search for things. You can use ChatGPT to do searches on problems. Uh, and I think that's where Stack Exchange is kind of falling behind because people can just use AI and get more complete answers. So the question from Christopher, yeah, that's about Python and using, well, really, I guess that's related to Anaconda. I'm not sure. There were comments above about UV. Uh, Complex software, mentioned that. So advanced users characteristics. So they could be hands-on faculty. So one of our hands-on faculty had a contract with the Department of the Navy to do CUI work, which is controlled but unclassified information. It's one of the higher levels of secure research environments. So he worked closely with us. He worked with not so much me specifically, but my counterpart who supports secure research to determine what the needs are, how to be compliant. Together as a team, they spend hours and hours working on it together. And then his research staff then would run the jobs, but he did a lot of the work to help us to get everything in place. So that kind of hands-on faculty, where you're working with them, is really great. Um, it could be the scenario where the PI does not actually do any of the computation his or herself, but they may have that dedicated staff person who manages the postdocs and grad students. And then they may just have PIs and postdocs or students, and then the students have to figure it out. So usually these advanced users have been doing this for a while. They're technically proficient, they understand parallelism and performance, and they can compare. They might run their code at other locations or might have come from another institution. So they know the expectations of what the code should be doing. They develop complex workflows. They know how to operate their software. So if they're doing NAMD, molecular dynamics, they've got connections to the developers. They know how to use the latest version. They know the features and know what's coming next. They read all the READMEs. They're also good at organizing their data, where their live data is kept, warm data, where they're moving data from other locations, the sources of the data. So they generate less of the requests, but typically they'll need assistance with complex software in the environments, but also with complex system issues. We've had a couple of cases. So one of the codes is VASP. That's also molecular dynamics. Well, no. Anyway, chemistry of some kind. So Vienna ab initio software program, something the Austrians came up with. Uh, the code would only scale to two nodes, and after that, it just wouldn't scale anymore, which was really weird, and it shouldn't have been doing that. And the vast people didn't really provide any help. But there was some Google information we found about when you exceed some core count. So what we do in those cases, we're really providing deep support. And so one of the uh, things we came up with was to move their code to one of the national resources. So we ran it on San Diego's system Expanse. And so we got an allocation there through Access, and we used our Access allocation and set up VASP on to use over on Expanse. And then so that particular researcher was able to get his code to scale properly. And then once he got it scaled, he then requested his own allocation on Access so he could scale his work off our systems and just do the more volume work on ours and then the high volume, the high scaled work on the national resource. So we've used that as an example case that we can use for other people. So uh, it's a great model. that when they want to do something that your systems don't quite support right, you can find a national resource that's set up for that, and you help them to run their jobs on an allocation on access is a big one. Uh, there is an alternative is to run it on AWS, if they've got money to run it over in one of those instances, but the money soon runs dry. Uh, that those monthly bills are substantial, whereas Access is a tremendously great resource for us to use. And then special requests, we've actually put in policy for some of our special requests. So the kind of thing that we support, as an example, is a research team says they have a conference coming up in 2 months, and they need to run their model 5 times, and each run takes a week. But they've already used their allocation of time. Can they get a extra allocation to support that project? And so we'll do an analysis. If their request for an extra million hours, say, of CPU hours, will not impact the community as a whole because we have enough capacity. We have levels of permissions required to get these special allocations, but we will support special requests that are beyond our policies, standard policies. So some other things for advanced users, treat them as peers. So and then use them as stakeholder advocates. So some of our most heavy users, our most prominent users are also some of our best supporters. So they will provide a lot of support to us, to people on the university who really matter, the stakeholders. They carry a lot of influence. When the most prominent astronomer, not the department head, but the astronomer who has the most reputation, when she talks to people and says that the astronomy department would be hollowed out, people would just leave if we did not have the support that we provide to the astronomy programs that we do. That carries a lot of weight. So paying attention to them, meeting with them, understanding their needs, just connecting with them regularly is really valuable. So uh, we have a committee usually set up when we do a purchase of faculty. So we'll include some of these different groups on campus to give input to our acquisitions. So it has a double benefit. It shows we're paying attention to their needs, but also they have valuable input. Like, do we need more GPUs, or do we need this kind of GPU and not so much the other one? Uh, do we really care about core count a lot, or do we care about how fast the processors run, gigahertz, for example? So they have a lot of valuable input. And then just by listening to them, it shows that we care and we build that strong relationship. So that's kind of the white glove support. We don't quite do as much of that yet as we want because we are somewhat understaffed at the moment. But the idea is that we proactively look at their work and the jobs they do. When we're having a system change, we might reach out to them and say, hey, we're going to be doing this. It might affect this workflow that you have. So we're getting ahead of things. So in that sense, it's extra support that we don't provide to the general community. Be flexible. You can make little rule exceptions. So I think just helping them out, anything that doesn't impact the community or create a sense of unfairness. If it's something that anyone could ask for, that's fine. And so we might offer these little exceptions like runtime limits or queue limits, anything that we can do without a major system change will often just help them out. Okay, so this next section is kind of focusing on the support teams. So as I mentioned earlier, I have 5 FTE. And this is the kind of work we do. I keep a dashboard of the work and categorize. So about a quarter of the time we spent working on apps. So that's building the software, supporting the software, getting it to run when it's not running right. We spend about a quarter of that time on data. So uh, file systems, directories, migrating data, uh, bringing data in, transferring from outside, putting it to a shared location, a community share. And then can see the slurm. The next one, that's how do I get my job's not running right, or I need help getting my job to run. It's a how to get things working kind of thing we spend. And then the rest of the time is smaller things. And I just note in there new PIs. I keep track of when we have an automated system for onboarding users and PIs. And the automated system generates an email that says this person just got added as a new PI. So I contact them with a hi there kind of message. Here are things we have to offer you. So in the 6 months year to date, we had about 40 new PIs. Other things in here, onboarding, training, problem determination, data storage. I'll get to some of those. These are the applications. I keep track of the software modules that we use. So in the year to date of 8 million module loads, you can see R, Python, MATLAB, the big ones. Let me move this, CUDA, PyTorch. So those ones are not surprising, but just the volume in the millions of module loads. I'll just point out something that we dealt with last year is when we migrated from CentOS 7 to Rocky 9, and we had to rebuild all of the software. It gave us a chance to clean out. So we went through and analyzed software that hadn't been used in 2 years or 3 years. So those ones didn't get rebuilt, and we just keep information about them in case that person does pop up and wants to actually use the thing that we didn't think anyone ever used anymore. So OS migrations are a good time to kind of clean house and reset, get all your versions updated. All right, so um, since we went with COVID all remote, what we started doing is meeting on GatherTown. It's just a neat little tool. It's kind of a cute visual thing. Question, are users running RStudio command line R? Those who are using on demand are often using RStudio, but if you're doing command line, we get a lot of that. And there are certain R applications that it's once you get them set up, so some of the geoscience ones are complex, and we encourage people to use R in a virtual environment through the command line. So I guess the answer is a mix. Why did you recompile under Rocky Linux? Okay, precompiled binaries are often not as fast as compiled software. So some things just come as precompiled binaries, and those will often work if they might be compiled for Ubuntu, and so then they're a little different. So you never quite know with the binaries. If you're just doing a simple installation of software and it just produces a binary for you, then we'll use those. So we do both. We compile the more complex software like LAMPs, but then we use precompiled binaries for simple software. Yeah, right. Yep, good point about like LAMPs. So this is our gather town where we meet up. So we meet at 9 o'clock in the mornings, and we only drop off when people start to get hungry for lunch. And so when you are not chit-chatting with someone, you can just turn your microphone off, turn the camera off. But then there might be some request coming in, and someone will just pop up. Hey, didn't we just deal with this case on this situation recently? And someone go, oh, yeah, I did one on that. And then, so there's a lot of interaction goes on. And I think it really helps with teamwork and people getting to work together, because when you're separated, everyone's work from home environment, or even in an office where you're separated by physical offices, a tool like this just really, really fosters teamwork and that sense of people enjoying being with each other as a team doing the same thing. And it also really, really helps with onboarding and bringing in newer team members because they can just ask questions all the time and not feel like, oh, I got a dumb question for you. You're more likely to feel I got a dumb question if you're writing it in an email. But if you're just chatting to the person on the screen with you, oh, how do I say this SSH keys again? And we're not going to go, oh, that's a dumb question. We got that written all over the place. You can just ask that stuff. So it's really fosters a good sense of teamwork. We use GatherTown for office hours, so it just looks a little different. The facilitators have their own office space, so when people come into office hours, they arrive in the middle there, and yep, GatherTown. And someone will meet up with them and say, hey, do you want to go join me in my office? You just kind of cursor along and meet in the office, so you can stand in the middle and chat. So it lets people just kind of chat and ask things, share screens, show them what they're doing. So we do that once a week. We use ServiceNow for ticketing. ServiceNow is okay. We get it from the enterprise, so that's what we're supposed to use. So that's what we use. It's good. We also have they before ServiceNow, they would send all of the requests to an email listserv. And then once we got ServiceNow, we stopped mentioning HPC-support. But yet half of all of our requests come through email to HPC support. Somehow everyone gets the word that that's how you contact us. So they do. So now we're turning that into a listener that'll automatically create tickets. And so we'll have a separate email list for chats that don't create tickets. And we won't tell anyone about those, although they'll find out, no doubt. But anyway, so we use ServiceNow. It's good. Uh, yeah, make docs at University of Nebraska. Nice. Yeah, make docs is really good. Uh, yeah, documentation. Since our documentation, oh, I need to change it. It's not .com, it's .edu. I don't know why I wrote that. So because it's findable by Google, we now have Google Analytics available, which is really good because we can see where people come in from, the volume, and where they land, the pages they go to, which ones they jump to and from, how long the sessions are. Google Analytics is really good. And if you look along the bottom, there's a dotted line and it pops up, the dotted line pops up just after April. That's when we put in our new Make Docs documentation. So you can see just in the year, we've got a lot more usage than we did when we first started. Okay, so we document our policies, and I think this is really important for two reasons. It gives you something to fall back on when someone says, well, that's not fair. You go, well, it is fair because everyone gets the same as subject to the same policy, and what the resources you get are the same as what everyone else gets. I didn't put this in big print or anything because I don't want you to read through it all. But anyway, the point is that uh, it's something that we can refer to, but it's also a guide for us. If we want to set a new policy because we're changing something, we'll go to our governance committee and get it approved by then. And then it becomes formal, it's in our documentation. So having formal processes makes you more professional. And then we use metrics. I think metrics are really, really important. Um, so now I created with one of our support folks to create an annual report. So that's in our documentation. It's linked on the front page. And I'll just have a couple of the things that are in the metrics. So research expenditures. The university, I think, has like $900 million of funded research comes in. And of that, around 400 million goes to PIs who have HPC accounts. We can't determine that they got the funding because of HPC, but this is like the best we can do. And if we're consistent in our methodology, it provides valuable data. So also the same with active awards by researchers. This is data that's available to the university, and we can align it with HPC accounts. This one is really good. I really like this page that I pulled out of our report. So the number of patents issued to PIs with HPC accounts, publications, citations, and then we can break down what the topics are of publications. So astronomy, given the nature of our university, specifically space exploration, astrophysics, astronomy, planetary science. So a whole bunch of them are astronomy related. And I think no report of ours is complete without quotes and stories. So we have a long story in there of something, support for a researcher that was really, really good. And then just this notion. This is something I think people probably dreamed of before HPCs existed, but isn't possible without the kind of computing power that HPCs provide. So this was an unsolicited comment from someone. So I was like, oh yeah, this is gold. So we include those kind of quotes. And then just want to finish this section with a reference to the facilitators need both hard skills and soft skills. So the last three that I hired, they all have PhDs, so they got the academic background. But one, her PhD is in statistics, and she had 10 years of practical experience in the medical field doing biostatistics. So super smart, super capable, and great people skills. Um, the other two, one was an astrophysicist, the other computational chemist. So same kind of things. I hire on their ability to know how research science works and their soft skills, how to get along with people. I'll just throw this out too that I'm a big believer in that. Uh, so DEI is a bad word these days, right? But the concept, I think, in the little letters is still really important, and I think it's important to have an inclusive environment. And if you encourage that kind of environment where people are welcome from different backgrounds, it's easier to hire people from different backgrounds. So um, I think providing that very welcoming, open, and supportive environment is really important. So question, do you support on-prem as well as cloud for research computing and storage? Pretty much no. We have limited GCC high for secure research. So we just do on-prem. I did an analysis. The system that we plan to buy, I took the same features of it and found an Amazon instance that's the same. It was going to be 10x the costs of running it compared to the allocations we were going to get from buying that same technology because new technology instances on AWS are very expensive. So another thing that we do is I believe in, I found this on our central HR called a team charter, and I found this framework for it. And I think having a common understanding of the things that are important to us is really valuable. So this has a vision statement, a team purpose, the team members, working agreements. So just pick up a couple of them. We commit to doing our best work. We hold ourselves accountable. We encourage a growth mindset. We treat each other professionally and with respect. So that sort of goes towards that inclusive environment. We foster community inclusion and support. So we have these written down, and it's just sort of an understood thing. And then the second part of it is we set goals for the year. So these are the goals, the things that we want to do for the year. And then underneath in the mauve color are activities that support the goals. So they're numbered the same as the goals. So there are 5, there are 4 activities. Only one is done so far because there's a lot of turmoil going on. I guess you all are caught up in a lot of the external turmoil. We also have internal turmoil. So we're kind of treading water at the moment in some regards. Uh, Teaching, I'll talk about that for a little bit. So the typical computer experience, right? So cell phones. So teaching, I'm going to go through this part a little quicker because this is sort of reference information. Uh, so breaking out those first ones, motivations. So you want for your teaching that what it's the right thing for you to be teaching and it's the right thing for the users to be learning. So our main objectives are to make onboarding easier so they can learn how to use the systems more quickly. So documentation plus workshops that reduces ongoing support needed, builds relationships, but also provides timely information. If they open a ticket or request a session with us, that's a day, 2 days, or hours. If they can find the information when they need it, that's really valuable. for the user, reduce barriers to entry. It's HPC can be really difficult to get going on. Formats. So we offer workshops. Uh, we do them in person sometimes when appropriate or on Zoom. We record them and put them on YouTube, and then we can track the YouTube views. We do consultations, again, either Zoom, occasionally in person, but usually on Zoom now. And then we bring in NVIDIA and MATLAB like to come and do presentations. So we do those in person. They'll send someone to come on site. Effectiveness. So you want to meet their expectations. So some practical guidelines for the workshops. We don't do quizzes at the end, and we don't currently have a survey, but we've done a survey a couple of times with a simple Google form, and that you ask, did this meet your expectations? Was the format effective? You can just get feedback in like 3 questions. There's always room for improvement. You can do self-assessments, like you think, well, I did a crappy job on that part, but I did a really good job on that part, and then you kind of make notes. Well, this part needs reworking. We should spend more time on this, less part time on that, so we can rework make our workshops kind of a live document, feedback, peer review, different skills for teaching. Uh, so these are the soft skills that I kind of alluded to earlier that the facilitators need to have. So we keep a calendar of the workshops we do. So you can see the first two are intro to HPC related. Those are in person. Then the next one, the third one, it might be small print, but we host the Pittsburgh Supercomputing Center workshops. And one of my team is a Deep Learning Institute certified instructor from NVIDIA. So this is a workshop. He taught fundamentals of accelerated data science with Rapids. So we have YouTube videos. So we have in there stories where I make recordings of people, and then we have trainings that we capture the recordings of the. Usually, if you do a workshop that takes an hour, if you run through it and just talk through it yourself without being in the room or without anyone listening, you can do it in like 40 or 45 minutes. So we'll often do those recordings separately because then anyone can stop, pause, rewind, basically. We do partnerships. So this is the university's data lab. They do more in-depth workshops. So next gen geospatial AI and cloud tools for geographic analysis. We don't get into doing that, but we have partnerships because they might use our HPC for examples or make reference to what we offer. Just have a few little bits on conflicts. So you can have conflicts sometimes happen. So it's important to remain professional, use your policies so that they can be HR policies, but if you're working with the users, that's where it's valuable having policies because you can point to those and say, hey, these apply to everyone. No one's getting special deals here. You're not missing out. I'm going to skip over these because otherwise I'll run out of time. These are some of the really useful external resources. Henry listed a bunch more at the beginning, but Access, Campus Champions, and Quark, I think, are three of the really useful ones. The NAIR pilot is supported by the NSF for AI, particularly. So you can have this as a reference. And then my last section is on stories. So I have a couple of examples here. So the policy abuser, we had one of those. We used to have one who would push all of the limits. He was considered our canary in the coal mine. So we would keep a track of what he did or what if someone complained about. He was pretty honest, but he was really good at working the limits. Sometimes he would misbehave a little. So we would find that out and we would tell him to stop what he was doing. But mostly he would be pushing the limits of what people could do. So if we realized our limits were too slack, then there was a chance for us to change our policies. So there was a little bit of abuse, but also it's the policy limit pusher, which is not abuse, but very useful to keep track of what that person does. Then the next one is the endless support requester. We have one of those, and this person shows up about every 6 months. Eventually, usually I have to get involved. And the last time I got involved, I talked to this person, actually set up uh, to meet on Zoom to chat with um, them and just say, hey, what are your needs? How can we help? My team is really limited on just how much we can provide. And I did some metrics. So between the beginning of the semester in January and middle of February when this happened, they had 42 different requests to us. Often they were along the lines of, okay, we give them a long, thorough answer, and they reply back, yeah, I'm still getting this problem. And that problem was exactly specified in the answer. So uh, that's how do you deal with someone who needs more help than just giving them answers? And then the other end of that is the epitome of value. And I think I'm going to skip forward quickly because I think I've got a bit more information on her work. So here's a story. So I like to collect stories, and it's as simple as recording a YouTube interview. So I will prompt them with three questions. What is your story? What is the science you're doing? And how does it involve HPC? So Emmanuel here's family were crop pickers in Southern California. So he was the first generation of his family. They were migrants to go to university, and he's studying plants under stress, under climate stress. So it's great science. He's got a great story. He's very eloquent, well spoken, so really good to record. So that was a great story to keep. The next one, Hayden is just starting in grad school, and she talked about how we helped her to get started to learn bioinformatics and how valuable it was to her. So these kind of stories help young people who might want to get into science, might find it a little intimidating to watch someone who's probably going through a similar path to them. Uh, a much recruited faculty. She's a cloud researcher, but not cloud computing, clouds that float in the air. So I've got a good story from her. And then we publish the stories in different places. So we want to get as much impact as we can. In this story of Elise, I made the cutout really small so you wouldn't be trying to read it. Um, but one of the gold quotes from Elise was, I know that one of the things that people have liked in my new position was this work I've done using computing and developing computational methods. So I think I would not have this position, or would be very different if I hadn't had access to HPC. So for her to get graduated, she got her PhD completed, and she's now got a faculty position, I think, at the University of Vermont. So she's super excited. She's just been there since the last semester. So the support we provided was really fundamental to her research. So capturing those stories and putting it in our newsletter. Um, Central IT also has a website where they collect stories. So this story was about the NEO surveyor mission to look for asteroids that might hit the Earth. So that's people love hearing these kind of stories because it's all about science and the really cool part of science and astronomy. There's so much cool science goes on in astronomy. So we want to capture that. It's also good for us as a team to know that the work that we support is really important to science and even important to the Earth, maybe in this case. Uh, so it's part of our job satisfaction is the kind of work that we do. And this one was a great story. This was my time filler. I actually have a video for this, but I don't have time to use it because I don't need to fill up that time. Uh, but Gertina Bessler is one of our premier astronomers. And she refers to $20 million in grants come from astronomy in less than 5 years. And these grants are awarded relying on the existence of our HPC facilities and the storage offered for their analysis. So at the bottom left is general relativistic magnetohydrodynamics. Yes, said it. The one at the orange one is a simulation of a black hole, which got a lot of publicity when it came out 5 years ago. And turns out that the actual black hole at Messier is very similar to the simulated one at the center of our galaxy. The bottom right is the interaction between the Large Magellanic Cloud and the Milky Way galaxy, creating a dark wave. So very cool science and very pretty amazing. So I've reached my time limit. So I guess this is where I invite Henry, or I don't know if we have time for questions, but Henry, back to you.
I think we can take a few questions. We'll go a little bit over, but we have a half-hour break, so if we have 25 instead of 30 minutes, that's probably not a crisis. Does anyone have a question or two for Chris?
Yeah, so I'll just talk while you're thinking of your questions. So I really encourage you to capture stories. So an interesting AI thing on the this one for Elise is I prompted her with those three questions, and she talked for 19 minutes, and it was really good. And I had a 19-minute Zoom recording, and I didn't know what to do with it. And then I thought, well, okay, I opened Microsoft Word, played the video, let it do uh, the dictation mode. So it created a 19-minute worth of words with no punctuation or grammar. And then I took that file and dropped it in ChatGPT and said, give me a 700-word blog with emphasis on these 3 points. And 15 seconds later, I had my blog written, and I just had to go in and tweak it because you can't trust what AI comes back with for you. But it's a tremendous tool if you know how to use it. So I turned that 19-minute long video audio into a blog in about 20 minutes. Melissa.
As someone who is in the current process of upgrading from CentOS to Rocky, what would you say was the most helpful thing to have documented?
That's a good question. Okay, so it's more complex than it seems because of dependencies. The software dependencies change, so there are certain things that won't work anymore that used to work, especially if people have built their own software. So communicating the changes ahead of time, I think would be the most important thing. We told people we were going to do it. We told them we were about to do it. We told them we were starting it, and we did it as a rolling update. So we rolled the update to a like a rack worth of nodes and told people, "Hey, here's the new image. Go try it out." And we gave them a couple of months to try out on the new image. And even then, you can tell people, "Oh, there's a change coming. You better adapt." Many of them just won't until, "Hey, my code doesn't work anymore." It's like, yeah, in our heads, we told you it was going to happen. So yeah, communication and a planful process.
All right, then I think we've come to the end of our session. So let's give Chris a round of virtual applause. Thank you so much, Chris, for a fantastic session. And you can tell by the amount of traffic in the chat that people were very interested, and there was a lot of discussion as you were going through. So our next session starts at quarter after the hour, so about 25 minutes from now. We're going to leave the session live. We're going to leave the Zoom session live. I will shut off the recording. And in fact, let me do that now.